In today's lecture, we're going to be talking about GUIs, and this is going to be part one of two parts where we're talking about just the various GUI controls in both Windows Forms and WPF. Now, I know what's actually kind of exciting about this class is most of my students tell me this is like the first time they've even programmed with a GUI, at least some sort of IDE. A lot of times maybe they're programmed in Notepad and added buttons and things like that, but we're using a modern IDE like Visual Studio where we can actually just drag and drop and create the visual content. So what I'm going to be doing in today's lectures, for some parts, I'm going to be jumping back and forth between Windows Forms and a WPF lecture. Now again, Windows Forms has been deprecated, so any new projects you would do in the real world, you'd always want to use WPF. However, there are so many projects and code bases out there done in Windows Forms that I still think it's a good idea to know both, but if I were you, I would do your assignments in WPF. That's just my recommendation. So now here with Windows Forms, we're just going to start going through some of the various controls. And so we've gone through the basic ones in the past lectures, just mainly buttons and labels and a few other controls. And today we're going to be going a little bit outside of that. So before we get into it too much, what I would like to do is just maybe drag a couple buttons on here. And I want to talk about event handling. So we had looked before on what it really means to click the button and have the click event wired up. So if I double click this, that means that this code is going to be called when I click this button. So how does that work? Well, if we come over here to our form designer and open up the code that it wrote for us, we had this piece of code right here. And you can see that it says for the click event, we want to call this button one click method, and it created this code for us. However, we hadn't had enough background in C# to really understand what was going on here. So that's what I'd like to explain first, because in all of event-driven development and some other things in .NET, you really need to understand the concept of what's called a delegate. So for example, if I highlight this thing that said event handler, it says delegate void system event handler, and it kind of gives us some parameters for a method. Well, what does that really mean? Like what is this new event handler delegate? So let's go ahead and take a look now and let's learn about delegates. So a delegate is just a variable that allows you to hold basically a pointer to a method. And it might be easier just to kind of see it and what that really looks like. So we use the delegate keyword, if I knew how to spell it right, delegate string my delegate. Let's do int I. So what this code does is it says, okay, I'm going to create a delegate of type myDelegate. The method that this variable can hold has to have a return type of a string, and it has to take an integer as a parameter. So let's create that method, what that looks like. So what's the first thing we have to do is remember our delegate is going to return a string. Now the method can be named anything you want. So we'll just call it my method. Now what does my parameters? It has to be int and then a variable. I'm just going to keep it the same, int I. So now we have, so let's just do return I dot toString. Again, what happens inside of our method doesn't matter. What we really want to do is create a method that had the signature of our delegate up here. All right. So now what can we do? Well, let's go ahead and create another method here, void test method, just so we can write some more code. And now what we want to do is we're going to create a variable of our type delegate. So I'm going to say my delegate. Well, again, we can name this variable. We'll say it holds method equals a new my delegate. Now watch what happens when I click this parenthesis. You can see it actually tells me, hey, point to a method that has the signature of my delegate. So see how it says whatever method you're passing in here needs to return a string, pass in an integer for an argument. Well, that's what my method does up here. So it will allow me to pass in this method. Another method would give me a compile error because it doesn't have the same method signature. So now inside this variable called holds method is basically a pointer to my method. So one thing you could do with my delegate called holds method is you could pass that to another method, or you could actually do something like this. And let's pass in like the number 3. So what is this going to do? Well, it's going to call this method here. It's going to pass in 3 and then just return 3 as a string. And that's what it's going to do here. So that's what delegates allow us to do. Or if you wanted to, we could say private void test2 but we could also pass in a parameter of type myDelegate. And that could be whatever, whoops, could be whatever you wanted. And so what this would allow someone else to do is to pass in a method that you could call. So see how it allows them to pass in any method they want, and then you can call it. So this way you can maybe have someone pass in a sorting algorithm or something like that, to where you need to allow them to tell you something to execute in here, and then you'll continue on doing your code. Now that should sound familiar to you. So let's go back to our form 1. So we took our button 1, we double clicked it, and it created this method. Now let's go back to our designer and look at this code again and see if it makes more sense to us. So now the first thing, we have not talked about events. So I'm going to skip over that just a little bit, and that'll be in a later lecture. But what it says is okay, here's what's called a click event. And what we're going to do is assign a delegate to this click event. And it's essentially doing exactly what we did over here. We're passing in a pointer to a method. And what we're saying is hey, for the click event, I want you to call this method. Well, how do you pass a method around? Well, you do that via these delegates. So notice right here where it's system void delegate, if I right click on this and do go to definition, and we just go ahead and take a look at it, you can see that this is all the code. Right? So here's our delegate keyword. We can see we expect the method handled by this delegate is going to return a void, and it's going to get passed into arguments. And they're telling us this is exactly what that method has to look like. And again, this should look familiar. Object center and event argz. If we come over here, object center event argz. And this is how .NET was able to just auto-populate this event handler method for you, because it knew what the delegate was and knew what its signature was, and so it could just create it for you and then pass it in. So that when you click the button, it says, okay, create a delegate. The delegate passes this method in, and it handles the click event. And so that way, you can then assign a method to the click event of any button. And this is true for all events in .NET. That's how they're handled. Okay, so now we've got that covered. So now let's talk a little bit more about Windows Forms, and let's talk about things like different windows and all the different forms. So here in Windows Forms, let's say what we do want to have happen is when you click this button, we want to open up another window. And this is a new concept that we haven't learned about yet. So how do we do that? Well, we can right click over here and say Add New Form. Now again, this is Windows Forms, and we'll talk about the WPF in just a second. And so we can say this, we'll just leave it at Form 2. Doesn't really matter what we call it. You would use it, create a more appropriate name for whatever assignment you're doing. So here's our Form 2. So now let's just put like a button on here, a checkbox on here, just so we know what it looks like compared to Form 1, so that it looks slightly different. Now, what we want to have happen is in our Form 2, or Form 1, we want to open Form 2. So what we can do is we can say Form, and see there's Form 2. We can say FRM my Form 2 equals a new Form 2. So now we've created an object of type Form 2. Now here's why students tend to get so confused when we're talking about opening up other windows and passing data between windows and things like that. Well, the reason is that because they don't realize that this form is just a class, just like any other class that we've created in our class. So Form 2, if I right click on this and go to definition, you can see this is just inside a class called Form 2. But the only reason it looks like a window is because we're inheriting from Form. If I were to do this, then it's just a perfectly normal class. Right? So is this easier to think through when you look at it? So now you would add properties. Like if you want to pass something to this form, you could just add properties or public method that could pass things into this form. So again, just ignore the fact that it's inheriting from form just to give some visual content. Everything else is just a normal class. So back to our Form 1, we've instantiated this object, and now we want to show it. Well, how do we do that? We do it with the .show method. And there we go. Now, what we can also do is there's another one called showDialog. And so these are the two different ways that you will call another form and show it to the user. And there's very specific differences between these two calls. So form1.show, what will happen is it'll execute this line of code. It'll execute this line of code, actually show my Form 2, and then continue on executing all the rest of this code. So it just executes this line, and then it continues executing on. Now showDialog is different. And we'll debug this code and show you in just a second that when it hits this line of code, it'll open up Form 2 and it actually pauses right here because we've opened up a dialog and we expect some sort of result back, or we expect not to continue executing until the user has done something in that Form 2, like close it down or submit values, etc., etc. So show dialog is a way of forcing the user to interact with a window before they do anything else, where show allows you to open up as many windows as you want and you can navigate back and forth between the windows. So let's take a look at that. So you'll notice I'm going to do string s equals this just so we have some code, and I'm going to set a breakpoint here, and then I'm going to set a breakpoint here. So let's go ahead and run our code now. Now when this pops up and I click this button, you can see I'm going here. Now when I press F10, see how this window now pops up over here and it continues executing on. Sorry, it was a little unhappy there. So it opened up my Form 2, but it continued executing right along. So now let me stop this, go back to my Form 1. And now instead of show, let's do show dialog. Set a breakpoint here. Now watch what happens, the difference here. Now when I click this button and now I press F10, see it actually jumps to my Form 2 that it opens up. And that's show dialog, so see how I cannot go back to this Form 1? It's forcing me to interact with Form 2 until I actually close it down, and then it continues executing on. So that's the difference between show and show dialog. Most of the time I use show dialog, but again, it just really depends on what you're trying to accomplish. Now another thing you'll notice that I chose to do here to keep it simple is that every time you click the button, it actually instantiates a new Form 2. So what that would mean is let's put a text box over here. Let's show the difference. So I'll put this blank text box, and now you'll notice that I've got form2.showDialog, and it doesn't matter show or show dialog, but I'm going to run it, and each time I click the button, it creates a new Form 2 dialog. So if I were to do this, click the button, here's Form 2, and I type something into this text box. Now when I close this down, it's going to destroy that window because it's no longer needed. It's a local variable. So if I click this button again, see how I've lost the state of this window? Because it's a brand new object. So that's something also to think about in your applications. Every time you want to display a window, do you want it new? Which is fine. It just depends on your scenario, or if you want to keep that window around in memory. Or is this window constantly opened and closed, and maybe the first time it's opened it takes a while to open, maybe there's some sort of initialization that it goes to a database or does something. Well, in that case you probably want to initialize the application when you first start up, but then only show it when it needs to be. So for example, we could do something like this where I could delete that, come up to our attributes, put this here. Let me get this out of here. So we're creating our object reference here, but now in our constructor is where we're actually going to initialize this Form 2, and now Form 2, every time it's open and closed down here, you can see that it's the same one. So now that state would be saved between openings. So again, it just depends on what you need it for. So now with that, let's go over to our Form 2, and I'm going to click on here and look at some of the properties. And so one property is this thing called dialog result. So notice what happens here on the show dialog. See how it returns a dialog result? Well, our Form 2, if we come over here to Form 2, you can see I can say this dot dialog result equals dialog result dot OK, or whatever. I can set it to a dialog result value so that when I come back from Form 1, just like a message box, I could actually have a dialog result here and set it equal to that. And that way I could know what a person catches. Or if dialog result doesn't tell me what I need, I could have another line of code here where after the user closes this down, I could say form2 dot, and I could access some property that's in my form12 that maybe I need to get the data. Maybe the user entered a username. So I could say form12 dot get username here from a property that I would have to create, and it could return me the data the user entered onto that window, like the user's name. So there's different ways that we can do that. So another thing, going back to these event handlers and this button click, now that we kind of understand delegates better, is that what we could actually do if we wanted to is you can have, that's why there's this plus equal sign. So if I wanted to, I could do something like this, button click to. Now I'd have to come over here and copy this method and do something like this. But now that I've done that, over here in this designer, when I click the button, it's actually going to call both of these methods. That's where this plus equals handle. Now it's rare I ever need to do this, but I just wanted to point out that you can do that here in .NET. So I'll go ahead and delete that for now so it doesn't do that. Oops. Get rid of that. Okay, so now let's go back to our form 1. So now let's talk about some main properties of our form. So we could go back up to, for example, the accept button. And one of the things is there's no way I can talk about every single property of the forms and buttons and things like that, so you're going to have to go through all of these, but I'm just going to kind of highlight some of the main ones, like for example, accept button. And it tells you down here what accept button does, is that if I were to set this, see how I get an option of button 1 or 2? What this means is when my form is highlighted, if I press enter, it's going to automatically call button 1 for me. So it'll call that method. Same thing for cancel button. See how I can set that up so if I press escape, now button 2 automatically its click event will get called. So let's take a look at some other methods here, properties here. So for example, we have what's called a control box. So notice if I do control box true, which is by default, and I run this, take a look here at the top right corner. So those are the control box. So now if I come over here, whoops, there we go, and go back to that control box, set it to false, and run this again, and you can see that now my window can't be closed down by the user. Right? So this is an example of I need to fully control what the user is doing with this window. I want them to interact and only interact this way. And so obviously this would have to have a close button or hide or something so the user can do that. But again, that just shows you kind of like the power that you'll have over your windows that you may need to use. Okay, so back to the control button. Let's set that to true. So another one, for instance, is cursor. So we've kind of played with cursor before, so as you highlight over a particular control, in this case the form, you can change the cursor. Another one, forms border style. You see how it's sizable? So that's, we could size the window at any time, but if we want, we could do things like fixed tool window. So see how that kind of gets rid of things up here? So there's various options that you can use that will allow the user to interact with the window differently. There's also other finer control like MaximizeBox. So if I say false here, you can see that this is going to be disabled. Same thing, there's a MinimizeBox. So just how you could set it. There's opacity. So you notice opacity is 100%. Let me change this to 50 and then run it. And you can see what now is it's 50% transparent. So I've yet to really need to use this, but it's fun to kind of make ghost windows. So there you go. But there may be times when you need to set that. So after opacity, there's things like text. So for our window, you notice this is actually the caption that it's going to display up here, which is something you always want to change. You shouldn't leave that to the default as form 1. Another one would be start position. So this one here, you can see default location, or you can force it to start up like center screen. This is something I almost always change mine to so that it always opens up in the center of the screen each time. There's also another one called, let's see, ShowInTaskbar. So that's whether or not the application can be shown down here. Again, maybe you only want the first window to show in the taskbar and not subsequent windows, because that could just make it so it just opens up window after a window down here in your taskbar, which isn't what you want. So there's things you need to think through for your form and how it's displayed. Now over here, we're talking about events. So just like buttons or labels, you can handle any event you want that's associated with your form, whether it's mouse down or mouse move or scroll or drag or drop. Anything like that can be handled within your form. So now let's jump over to our WPF app. Now what's nice is WPF app for the most part handles new windows the same. There's some slight differences with opening and closing, but there's another lecture on how to do that. So let's just talk about our window in general here and talk about some of the properties. Now in WPF you can sort it by name or you can sort it by category, completely up to you. For some reason I like name. I just found that it's easier to find some things this way. So our WPF window, the other thing you want to be careful of in WPF, when I click here, notice how it's highlighting the canvas that I've created and not the window. So to get the right properties over here, you have to click here on the window and now they'll start showing up over here. So in WPF we've got things like the background, and we have different type of backgrounds. We can set it to like a gradient, or we can have something like a tile brush. And then down here we can actually mess with the tab stops. And then so you can see how I can actually change these different gradients for our background, or we could have set it to like a color, something like that. WPF has the same kind of situation where you can change like the cursor. So here's another cursor property. We could also set things like the icon, which would be a good thing to set. There's resize modes, so you can see no resize, can resize. And so again, everything in Windows Forms is going to be able to do it in WPF, but there's just going to be some slight differences on how you have to do it. And so in this WPF app, it's called ResizeMode for this. There's also like ShowInTaskbar, so another one that we've said. Here it's called title instead of the text property. That gives us our caption up there at the top. And then we also have things like WindowStartupLocation, WindowStyle. So they're just other things that we need to look at when you're creating each window. So if we go back to our Windows Form app again, let's go ahead now and let's drag a text box over here. So we've worked with text boxes a little bit, but now we're going to cover a little bit more of the properties that you'll want to look at. So for example, we have one that's called CharacterCasing. So you'll notice that if I want to, I can force the CharacterCasing to be upper or lower. Well, that's nice. If you expect something to always be capital or lowercase, might as well just force the user to enter it that way. Also, another thing you almost always want to set is here this max length. There's no reason that someone needs to enter 32,000 characters into your text box. So, for example, if there are only 10 as the max character, maybe this is a name and the first name is only 10 characters in your database, well, the user should never enter more than 10 characters. So you always want to try to limit things where the user can enter too much. There's also what's called PasswordChar. So if I were to enter a star here, then any text I enter, you can see that it's going to act like a password field. And so now it does that. So pretty simple just to do that. Let's go ahead and delete that. So now we can also look at things like, how about read-only? So read-only, if I set this to true, it doesn't make any difference visually, they just can't type in it. Where something like enabled here, is what's actually going to force them to not even be able to enter any characters. There's also TextAlign, so we can change to left, right, center. We've also got TabIndex and TabStop. So TabStop just says whether or not this control, when you press the tab, should be enter into it. TabIndex shows you that. So notice how here's 0, here's 1, and here's 2. So as I press tab, it's going to tab between these different controls. So you can set the tab order, and this is something you almost always want to do for about every application. Most people tend to forget this. Come back over to our WPF app. Let's drag a text box over here. And now, as we go through here, you can see I can scroll up. We've got things like CharacterCasing. So as we found it, let's see. Oh, got to click on text box. Here's CharacterCasing. So you got normal, lower, and upper. We have things like FlowDirection. We have IsReadOnly and IsEnabled. So based on what you need it to do. And we also have IsTabStop. So if we come down here, you can see IsEnabled, IsReadOnly, IsTabStop. And so it's kind of the same that as Windows Forms. And then down here, you can see is where our actual tab index is that you'll have to set for each of the controls. And then in WPF, it also has max length, so another thing that you're going to want to set rather than just the complete number of characters that you allow them to do. So now if we go back to Windows Forms, let's talk about some new controls now and a little bit more of their use. So for example, let's try the GroupBox. So a GroupBox in Windows Forms is used to group controls together. So they're all part of the same group box. So what's nice about that is they're all together, so you can move them all as one. Or if you enable or disable or hide this group box, it does all the sub controls within it. And it allows you to have this caption up here for your control that you can set. That's this text right here. Now if we go over to WPF, you can see that we come down here and we've also got a group box. Oh, there we go. There's our group box. We didn't need to make it quite so large. Let me grab that, move it down here. So here's our group box. Now in WPF, it has a header. Now in WPF, we can add various things to our group box, just like we did in Windows Forms. So here's our end of our group box. We want to end it there. And then inside of our group box, we could add things like if we wanted like maybe a label, if we wanted a button, things like that. knew how to type. Okay, so those would get added into our group box. Now, I did this on purpose because notice what happened when I added a label and I added a button. You can see property content is set more than once. So some of these controls are what are called content controls, and what that means is that you actually have to have a container control, like say a canvas, inside of it. So it can only hold one control. That's why you need another control within it. And that way we can actually put, our label in here, so you can see it's just kind of sitting there. And we've also got our button here, which you can't see until I put some text in it. So this actually does have those, two controls in it. We can add as many as we want, and that's how the group box works in WPF. Back to Windows Forms, we have what's called a panel. So a panel is like a group box, and so you can just add different things to it. You can set the background, for instance. It doesn't have the same caption around there. You can set the border around it. It gives you a few more different properties. Now, with talking about these panels and things, let's talk about checkboxes now. So if I drag a checkbox on here, you'll notice that checkboxes can be checked or unchecked, and there's no group to them. So it's not like you can only have one checkbox checked. If you want that type of functionality, you'd use a radio button. Now our checkbox has what's called the checked property. So right here, so we set this true or false, that's how we set this, and we can do the same thing in code. Over in WPF, our checkbox is going to be very similar, except our checkbox in this is going to have what's called isChecked for a property, and that's how we set the isChecked to true or false. Now the next control I want to talk about is a radio button. So if we take our radio button and we drag it over here, now I'm going to drag a couple of radio buttons here, and I'm also going to drag a radio button into my group box, and then another radio button into my group box. Now what I'm going to do is I'm going to run this application, and now we've got 4 radio buttons on here, but notice that these two are grouped together and these two are grouped together. That's because this one is contained within a window, so they're in the same group. This one's in a group box, so they're contained within the same group. So that shows you that if you need multiple groupings, you need some sort of control to hold your radio buttons. Same thing is true in WPF. However, there is one other thing that you can set here, and that it's called, if we look over here, group name. So you could actually set the group name of multiple controls and they would be in the same group. However, I would recommend you do that via some sort of container control. So in both WPF and Windows Forms, we have different ways of displaying images. So for example, we've got the picture box, which we've used before, and we set the image property in order to set an image there. In WPF, we have an image control that we would use in order to show image. So now with that, I'd like to jump over to an application from our book and kind of show a little bit more about event handling. And so this particular application has nothing on the UI. It's figure 1438, and what it is when I run this application, it's a painter application. So if I hold down the mouse and draw with either the left or right mouse button, it just draws some circles, and you can see everywhere I go it just draws a circle. So now let's take a look at how they did that. So if we come over here to our form, and then we look at the events, not the properties, and we scroll up to the top here, you can see as I scroll down here, there's 3 events that they're handling: the mouse down, the mouse move, and the mouse up. So mouse down is basically telling our application, hey, you should start painting now. Mouse up says stop painting, and mouse move says draw a circle in whatever spot the mouse is. And so it just draws a whole bunch of small circles, and it kind of looks like a line. Not the best way to do something, but it gets the point across for how we do this. So we've got a global variable that's just telling us whether we should paint or not. If we mouse down, we set that to true. Mouse up, we set that to false. When we move the mouse, we say if I should paint, the mouse is down. Now, this graphics object, let's not worry too much about that. It just gets a little confusing, but we're just saying we need to create a graphics objects for our window so that we can paint some stuff to it. And so everywhere we move our mouse, we're just going to fill an ellipse in. So this is really the code I want you to look at. Notice how it just creates this solid color brush, and it creates an ellipse, and it puts it wherever our mouse is at. And it just makes this as how the width and height of that circle. So just showing you how you can actually handle events and do some event handling there. So let's take a look at another example from our book called Key Demo. Now this is a great demo for how to validate user input. And this is very handy on some of our assignments. So notice what happens is as I run this window, we're handling events on the window itself. So for example, if I press the F key and I hold it down, you can see key pressed is F. Is the Alt button pressed? No. The Shift button? No. The Control button? No. The key code, which we'll look at a second, is F. The key data is F, and the key value is 70, or the ASCII value. Now I could hold down Shift, and you can see it actually tells me, yes, the Shift is pressed down. Key code is Shift key, data is Shift key, and key value is this. Now I'm pressing Shift and F at the same time. See how it actually, I can tell, hey, the Shift is pressed, and I'm still getting this F as a key code. So let's take a look at how they're actually doing this now. So if I come back to my window, and I click on my window, come over here to the events, you can see that there's 3 different events that they're handling: the key down, the key press, and the key up. Well, each one of these events gives you different pieces of information based on what you need to know about the key press, or the key down, or the key up. And so let's take a look at what the key pressed event gives you. So you can see it passes in what's called a key press event args. So when you handle key pressed, they pass you different information. So if I said E dot, you can see that I've got a few different things. For example, the main thing that we care about is what's called key char. And you can see this gets or sets the character corresponding to the key pressed. And notice that it actually returns a char. So it returns me the exact char that was clicked. So that's what this is telling us here. So if that's all you care about is getting the character itself that was clicked, you could do key press. Now key down is what you would use for, like it's telling you, modifier keys, such as Alt. So notice this passes in a key event args versus a key press event args. So when I say E dot now, there's different things that I can access, like Alt or Control or key code. For this is gets the keyboard code, key data, it gets the key data, and then key value. And you can see that they're different types. So this is a key event args.keyValue. This is a keys. This is another keys. And so this is the code they're using. And they're saying if E.alt, if it's true or false, pass in this. Same with Shift, same with Control. So if you need to know if those characters have been pressed, you would handle the key down, not the key press. Key code, again, if I highlight this, you can see it's what's called keys. And so if I were to type in keys dot, you can see that these are actual keys that I can say. So for instance, key.c. And so I could actually do an equal sign here and see if the user, e dot, key code, and see if they are equal to each other. So it gives us some more pieces of information. The key up now, we're just clearing out the data is all it's being done here. So again, we could use this data to filter out the user input. So if we only wanted to allow numbers or letters to be entered, we could use our char class that we'll do in just a second, and we could use this kind of key up or key down functionality to figure out what the user clicked and how to handle that input. So let's take a look at a couple examples now that I've created for us. This one's the Chapter 14 Windows Form Timer. And so we want to learn about this because this is a timer is going to be used in some of our assignments, and it's really a regular thing to do in our application. And so what a timer does for us is it says, okay, at some regular interval, we want some event to be fired. That's all the timer does. So if you need to do something every second or millisecond or every 10 seconds, or display a timer to the screen, you can use in the timer class. Now this is for Windows Forms, and it's different for WPF. So what we can do for our timer is we can instantiate a new timer. Then we can access the interval property. Now notice that it says here this is in milliseconds. That's why I've set 1000. So that says that this timer is going to go off every 1 second. Now here's another reason that we had to learn about events and how these event handlers via delegates. So here's the tick event, and we want to tell this timer what to do every time this tick event goes off. Well, what does it do? You'll notice that it's going to call this my timer tick. Now down here, here's my timer tick. Now if I highlight event handler, look what it tells me. I need a delegate. The return type of this method needs to be void, and it needs to pass in an object sender and an event args e. Sure enough, that's what I've done right here. So it expects a method to look with this signature, so that's what I've done. I've just instantiated a new method, and it's going to call that. Now, if I were to do this real time, watch what happens. If I say plus equals, and then I just press tab, it'll actually go ahead and just create an event for me right here. And so this is actually just a shortcut for this up here. Either is just fine. And you'll notice that both of these are actually going to get called whenever this tick event gets raised. So that's how that works there. So let me go ahead and delete this now, because we don't need this extra one. Now, when the user clicks button 1, I'm going to say myTimer.start. So this is what starts this interval and this tick event going off every second. Now, it calls my method, because that's what I passed in every time this tick event goes off. And I'm just going to write out to the screen the current date time. So let's take a look at that and let's run it. So when I click this button, you can see that now the time is going to get printed out every second. I'm just updating this. Now, kind of more for our assignment, if you really wanted to, instead you could create something like int I equals 0. Every time this method goes off, say I++, and then set lbltimer.text equal to I.toString. And then maybe comment this out. So what's this going to do? It's just going to continually increment the number of seconds that have gone by. You can see 1, and it's going to, etc., go on. So this is a way to create like a counter that we need to create, save the state away. That's why we needed to have some sort of class level variable to do this. So go ahead and just get rid of all this again. We don't need that. So the next part of this example, I want to talk about more of that user input. So almost all applications that I create, I do something like this, where I always want to help the user along and validate the input that they're entering. So in this particular example, what I'm saying is I only want the user to enter numbers. Now you have to be a little bit careful with things like this, because think about it this way. So if I enter the numbers 1, 2, 3, 4, 5, but I want them to be able to backspace these characters, or I want them to come in here and be able to press the delete key. So you have to be kind of careful on what you want this user to do. So now if I press A, B, C, D, E, F, see how it doesn't print it to the box? So I'm typing characters, but it only allows me to enter numbers or press the backspace key or delete key. You really need to think through that. So what I'm doing here on my key input press, the first thing I'm going to do is I'm going to use the char class. Now remember, I'm using the key press event. So if we come back over here, again, I'm just using this key press event, not the key down event, because all I care about is this e.keychar in order to do this. I don't care if the user is doing shift or alt or anything like that. So the first thing I do is, okay, let's just look, have they entered a number? And so if they actually do enter a number, because I've got this not sign here, it's actually just going to skip over this code and do nothing. So let's watch that happen. So I'm going to run this. Now if I enter in like 3, it comes here and I do F10 and it just does nothing. See how it just skips over that code and it prints the number 3 to this box. But let's watch what happens if I press A. A comes in here, but it's not a number like I care about. So I come in here and I say to myself, well, did they use the backspace key? So I looked up what the backspace key was, and it's a 8 in ASCII. So I say, did the user press the backspace key? If so, it actually will just do nothing and then come to the end of the code, so it'll erase that character and just go on. But it's not. Did they press the enter key? So this is me just showing you an example of maybe the user needs to do something like submit the data when they press enter. Think about a web form application or any other application in Windows. If you enter a bunch of data, you don't want to have to grab your mouse and then run over and click enter. Sometimes it's nice to just be able to press enter. Well, that's how you would do this here. And so I'm going to press F10. You can see it skips over that because they didn't. Next, did they enter anything else? So it wasn't a backspace, they didn't press enter, they didn't press a number, so what do I want to have happen? Oh, e.handled. And so what this says is this prevents that character from even being put into the text box. Because I'm saying, hey, I've handled this event, don't do anything more. And because there actually is extra code that's running from that key down press. So now if I do F10, because I've handled the event, and I come out of this, you'll notice that it did not input the letter A. So that's one of the things you want to do with any user code. Now if I come over here to WPF, let's scroll back to the top. Now in order to use what's called the dispatch timer versus on our Windows Forms application, we use just the timer. In WPF, we have to use what's called the dispatch timer. Now, there's some things about threading that we'll get into later on, but this dispatch timer executes on what's called the UI thread. And so we'll learn more about that later, but I just want to point that out now. And that's also true for this timer class over here. So anything you do in this timer tick, you can update the UI if you would like to because it executes on the UI thread. And that's the same for this over here. If it didn't execute on the UI thread, you couldn't write to because it's two separate threads executing in parallel, and so you can't access the UI thread from a separate thread. Again, we'll talk about threading later on. I just wanted to point that out now. So we have to use what's called a dispatch timer in WPF, and it's slightly different, but it's very close to the timer in Windows Forms. So first we instantiate this in the constructor, and now rather than set the interval in milliseconds, the WPF timer, you can see, holds something called a time span. So we have to use this time span structure, and it gives us a little bit more granularity. For example, I can say dot from days, hours, milliseconds, minutes. So the other one was forcing you to do milliseconds. So you would have to do that calculation, for instance, if you wanted the timer to go off every day. Well, in this case, it's a little bit more helpful that we can just say from days or from hours. So in our case, we're doing from seconds, and we're just going to pass in 1. Now, just like in Windows Forms, this is just using delegates to say which method should go off whenever the tick event happens. When they click the button, I'm going to start the timer. Every time my timer goes off, I'm just going to update this label to the date time string, exactly like Windows Forms. Now down here, I would like to talk a little bit more about the date time and the time span objects, since we've been learning about them a little bit. So date time is something that's a variable that we're going to use just to hold a date and time. And there's lots of different formats and lots of different ways we can do that. So here you'll notice that in order to set our date time, we can do something like datetime.now. So we can just get the current date time. Or if we want to, we can have multiple date times and we can do things like subtract. Or in this case, here's our second date time, and we can add a certain number of days to it. Or down here in our time span, which is the difference between two dates. So if I have date 1 and date 2 and date 1, I can subtract date 1 from date 2 using this built-in method, but that returns me a time span object. And then you can see down here I can use my time span dot, and you can see that I can access the different total days, hours, minutes, things like that between the two based on the information that I'm trying to get. Now down here, it's slightly different for WPF when it comes to how to handle these events. For this one, I'm going to handle the preview key down event. Then what I'm going to do, I'm going to come in here, again, it looks slightly different in WPF, but let's take a look at just this section of code right here. So for this key event args, if I say e.key, you can see that it returns me a key data type. And so what I can do is say if e.key is greater than or equal to key.d0. Now this is the keyboard, the 0 at the top of your keyboard. So I'm saying, is the key pressed greater than 0? And is that key pressed less than 9? So I'm saying, is it between 0 and 9? Or has the user entered 0 through 9 using the numpad keys? Okay. You'll notice I'm using the not sign here for all of this. So if a number is entered, it's just going to skip over this. But if they didn't enter a number, then I look to see if they press the backspace or delete keys. And if one of those was not clicked, then I handle the event. Kind of the same idea that we did in Windows Forms. So this has kind of been a basic lecture on some of the new GUI controls and just how we can handle events. Hope it made sense, and just let me know if you have any questions.